Welcome to qnawire.
Now this question we want to find what is the probability function in which for any given r we want to find what is the probability that the electron will be found outside of this sphere of radius r. Now that is quite a weird way of phrasing that. So basically what we want is to take the actual probability density function of our ground state hydrogen atom. Right, this is our probability density at r prime NER. Then we integrate from r to infinity. Right, this is outside of the sphere r, and so we integrate the probability density outside of r to infinity times dr. So we know the probability density function for a1s orbital for the hydrogen. It is for a0 cube prime square exponential negative r prime over a0. So remember that we're integrating from r to infinity, and overall integral we should get this is using the integral table. So from r to infinity, so at infinity the value of the exponential term will go to 0, so the entire thing will be 0. And whereas for when r prime is equals to r, then it's not 0, so the only surviving term is the r prime when r prime is equals to r. So this is 2r square. Now what we want to find is actually a graph of this probability against r over a0. Right, so r over a0 is our x, so we can substitute that to be x squared plus 2x plus 1 times e to the power negative 2x. So this is the graph that we want to draw. And it is quite simple. What you want to do is you want to substitute r various values of r over a0. So we are given that r over a0 should range from 0 to about 4, and we want in steps of 0.25. Right, so substitute r over a0 as 0.25 into the equation and find what is the probability. Now I'm gonna give you a rough graph, but you should be able to do it quite easily. Just substitute values inside to find the probability. Now at 0, this should be 1 maximum probability of finding it outside of this sphere of radius 0, definitely. Then it should subsequently decay downwards, and then it becomes an exponential decay over to 4. It's very, very close to 0, but not 0. Right. Now to find what is the probability we want to find the value of R, where the probability of finding electron outside the sphere is equals to the probability of finding electron inside. So in this case, this must be equals to a probability of half, right? Since if it's half inside, it means that it must be half outside to conserve the total probability of 1. So in this case, what we want to find is we can just look on our graph where the point is 0.5, and we look at over here, your graph should show a value of about 1.3, around there. So what I'm going to do is you're going to substitute this value into your calculator or a software such as Mathematica to solve for the equation which we have actually found earlier on, right? This equation equates this to half, and we can solve for this equation in a software while giving it the starting point to search for the solution to be about 1.3, right, where x is about 1.3, and using a software such as Mathematica, you should be able to get that x is equals to 1.34, right, the nearest answer. And so this is r over a naught, it's 1.34, and so it means that our r that we need is 1.34 times a naught.